Hello everyone. So for today discussion session, it's about shift resistance. Uh, quick reminder about what we just saw in the previous materials. There are two major types of resistance for the ships: the frictional resistance and the viscous resistance, and the residual resistance, which is the wave making and the eddies. First, a short introductory question for what you saw before and what you know. Why do we need to estimate these two types of resistance for a shape to design a shape?
We need to estimate the resistance in order to have another estimation of the power of the engine.
And maybe if you think about the forces applied on the earth, why do we need to know that?
Well, for the how to resist, and also maybe to design to know where the most resistance will be, and then to design the best hull shape.
Any other? So for estimating the ship resistance, there are a lot of methods, but here we will focus on two, which is the CFD and the real model testing. Can you think about for each method some advantages and disadvantages?
Advantages for CFDs must be like the price, and it's cheaper to just analyze it on the computer. And the time is also faster.
Also, advantages, you can create any condition you want. You don't have to. So it goes with the time as well. You can do winter in summer.
The disadvantage of CFD is that there are many types of different CFDs, but for some of them it's kind of difficult to actually predict it for very complex hull designs that you would see in actual ships and how the flow would be distributed around the vessel. So yeah, some CFDs have very limited accuracy compared to actual experiments.
Model tests have a disadvantage about scaling, because it is impossible to make a real engine model. So in test and real situation, there's many. We have a scaling problem, and for example, Reynolds number will different, and it is impossible to believe it. It is impossible to same phenomenon to make it as
from the real scale shape on the prototype is different.
Yeah.
Maybe the advantage for MLB testing.
Maybe accuracy.
And I think although the scaling is different, you can use like the Frown number or also some modeling in human mechanics to model from small size to large size. So yeah, you can use calibration to calibrate viscosity changes or other types of things like which scale becomes important in large scale. So
And maybe model testing is quite intuitive rather than the CFD model.
It is what? Sorry.
Intuitive. I mean, it's very direct method to calculate the resistance.
Yes. Okay, thank you. Then we also saw that the shape of the ship is really important to save energy as there is less viscous resistance. And as the nature is well done, today researchers and ship designers sometimes use the pre-existing shape of marine animals to design underwater vehicles, ships. So regarding these different viscous resistance, drag resistance factors with the different shapes, and you try to rank these different animals with their efficiency in the water.
Just looking at the name of the first fish, he's a boxfish, so I think he's the slowest of the six. The last. I think those would fish is number one because I heard that that fish is the best fish in the world. Second, I'll say the dolphin because I think they go pretty fast to catch other little fishes for their.
I think a bullhead whale is number 5. But it is similar to a bulk, but it is actually, I think, quite similar to the boxfish in terms of efficiency. But boxfish is very slow, and the bullhead whale is very fast. So we operate at different Reynolds numbers.
I think number 3 is penguin because penguin fish is fish. So penguin have to faster than fish.
So, do you, does somebody have a different opinion or agree with this ranking?
Well, I guess there are many different types of eels, and it really depends on the species of eel.
Yes, actually on the website I used, according to the different types species of penguin or else. These 3 or 4 position can change, but it's still people. So, for example, can you try to associate any of the animal with these different shapes? For example, the whale.
The way it looks like the bullet.
This one.
Yes.
And the other. That's one.
I think the swordfish and the dolphin both are like aerofoil.
So, this is also how they use to predict from the different animals their resistance using this kind of observations. This is my references, and thank you for your participation.